Assalamualaikum, very good afternoon to all students. I am Dr. Sharif Fauzi Kaprozaman, here to deliver you a lecture for Data Communication and Networking for Chapter 5 Number System. Thank you for all subscription and likes that you have given to my previous videos. Hopefully, this video will be beneficial for you as well in your studies and for your assessment later on. So today, the topic will be a number system. So the number system basically is not a new topic for the students in UMP currently, because we already conduct this within your first semester under computer architecture and organization. So the number system is one of the crucial components for data communication and networking, since most of the addressing is conducted by using a number system. Either it's a binary or whether it's hexadecimal, all of them representing an important part in our communication architecture. So most of them are created based on binary number system. So what exactly binary number system? So binary number system consists of ones and zero chord bits, and decimal number system, they consist of 0 through 9. However, host, server, and network equipment using binary addressing to identify each other. So each address is made up of 32 bits divided into 4 sections called octets. So each octet contains 8 bits or 1 byte separated by a dot. For ease of use by people, this dotted notion is converted to dotted decimal. So in order for you guys to understand how IPv4 addressing work, we need to look at in form of binary. So example in this figure, you see that a host, within a network, they have this binary as their addresses. So in order for you to understand what kind of address that they have, they convert all this binary into decimals. So this one is easier for you to analyze which address is for which devices. So binary, they have a positional notation. So positional notation means that a digit represents different values depending on the position the digit occupies in the sequence of number. The decimal position notation system operates as shown here. So like for example, this represents from 1 to 9. So this one is 10th. This one is zeros, this one is tenth, this one is hundreds, and then this one is thousands. This one is basically ones. So ones represent the value of decimal times 1. Tens represent value of decimal times tens. Hundreds represent value of decimal times hundreds, and thousand represent value of decimal times thousands. So when you add them up, you can get a whole number, which is like here we have 1 for thousand, 2 for hundreds, 3 for tens, and 4 for ones. You will get total of 1234. So binary operates a similar way. They have for ones as 2 power of 0. For 10 is 2 power of 1, for hundreds is 2 power of 2, for 1000 2 power of 3, and so on up until in case of 8-bit becomes 2 power of 7. So each of them in decimal represent a different value than the decimal representation. So like for example, 2 power of 0 represent 1, 2 power of 1 represent 2, 2 power of 2 represent 4. It's basically a power of 2 value of each bit's location. So like for example, if it's in location 7, so it's 2 power of 7 means that it's a 128. So if you have, like for example, a binary number of 11000000, it works similarly as this value, the decimal value, times the 2 power of 0, and then the 0 value, decimal value, times 2 power of 1, 2 power of 2, up until 2 power of 7. And then you total it, and you will get the value of the binary in decimal. So to convert the binary into decimal, okay, you need to remember basically the power of 2. So the first location of the power of 2 means that is a 2 power of 0. Second one is 2 power of 1, 2 power of 2, 2 power of 3, 2 power of 4, 2 power of 5, 2 power of 6, and 2 power of 7. Okay, and then when you got the binary number, that for example 11000000, you times with the 2 power of the location of the number, you will get the value, and when you total all the value, you will get the decimal value of the binary. Okay, so let me demonstrate to you, okay, how you do it when you want to calculate it by your hand. Okay, I have a piece of paper with me. Okay, hopefully you can, okay, you can see it clearly. So this one, okay, like for example, I give you, okay, 192, and you want to convert it into binary. So basically, okay, you just draw 8 boxes that represent the 8-bit. 1, 2, 3, 4, 5, 6, 7, 8. So this represents 2 power of 0, 2 power of 1, 2 power of 2, 2 power of 3, 2 power of 4, 2 power of 5, 2 power of 6, and 2 power of 7. Okay, so when you want to calculate the binary for this one, okay, 192, okay, basically you find out the closest power of 2 to 192. Okay, okay, if you want to calculate what is the closest power of 2, you can start from the beginning, 0, okay, 2 power of 0, and then you got 2 power of 0, which is 1. Then 2 power of 1, which is 2. 2 power of 2, which is 4. It's basically the double of the number previously, which is times 2 the number of previously is 8. 2 power of 4 is 16. 2 power of 5 is 32. 2 power of 6 is 64. And 2 power of 7 is 128. Okay, so you subtract all these numbers. Okay, you subtract the original number with the number from the timetable. Okay, for example, if the closest number to 192 right now is 128. So you subtract 128, means that you got a balance of 64. So here 2 power of 7 will become 1. And then 64 is 2 power of 6. So you subtract 64, the next closest power of 2 means, okay, 2 power of 6, then you got 0, and then 1. Then you got 0, the next closest power of 2 is 0. So all of them become 0. 2, 3, 4, 5, 6. So 192, okay, you'll get the value is as shown here. Okay, 11000000. Okay, so let's demonstrate the second binary that we have here, which is 168. Okay, so 168 is the binary is here. Okay, you have on the 7th, okay, on the 8-bit, which is 1. Okay, 10101000. So from 1 here, times at the 2 power of 7, which is 1 to 8, you got 1 to 8. And then you have 0 and 1 times 32, which is 32. 1 plus 1 times 8, which is 8. And in total everything, you got 168. So again, I would like to demonstrate to you how do you do it the other way when you want to get the binary for 168. So here I got a paper with me. So you want to calculate the binary of the 168. Okay. So firstly, you need to draw 8 boxes, 3, 4, 5, 6, 7, 8. And this one is 2 power of 0, 2 power of 1, 2 power of 2, 2 power of 3, 2 power of 4, 2 power of 5, 2 power of 6, and 2 power of 7. So draw the power of 2 table first. Okay, so you have 2 power of 0 is 1. Okay, 2 power of 1 is 2. 2 power of 2 is 4. 2 power of 3 is 8. 2 power of 4 is 16. 2 power of 5 is 32. 2 power of 6 is 64. And 2 power of 7 is 128. Okay, so let's start by analyzing the closest power of 2 that you have first. So the closest power of 2 to 168 is 128. So you subtract with 128. And then you got the remaining one is 40. And here, if you can successfully subtract from it, you put a 1 at the location of the number that you subtracted. 128, put 1 at 2 power of 7. Then you got a remainder of 40. So you choose the next power of 2, the close to 40, which is 32. So put in 32, okay, subtract with 32. Okay, this one is 2 power of 5. Okay, and then you got remaining 8, so 32, 2 power of 5, put 1 in the 2 power of 5. Then you got the remaining is 8, the next closest power of 2 is 2 power of 3, which is 8. Okay, subtract with 8, and then you successfully got 0. So here, 2 power of 3, you put it 1. And then since it's got 0, the remaining one will become 0. And the empty one will become 0 as well. Okay, so you'll get the value of binary for this number 168 as 10101000. Okay, next let's take a look at 11 and 10. They use the same concept. Okay, for example, okay, you got an 8, a 2, and a 1, and then you got 11. So 8 means 2 power of 3, 2 means 2 power of 1, and 1 means 2 power of 0. And then you got, okay, 10, which is 8 and 2, which is 2 power of 3 and 2 power of 1. Okay, so when you want to convert from decimal to binary, okay, so you need the binary positional value table is useful in converting a dotted decimal IPv4 to a binary. Okay, like for example, here what I did before, if you look at 128, okay, if the value is more than 128, okay, you subtract with 128, okay, you subtract with 128 and put 1 here, okay, then you got the remaining one with 64 next. If the value is bigger than 64, subtract with 64 and then you put 1 here, okay. Then continue up until you get the 0. Okay. So as what I showed before, okay. So if you have 168 is bigger than 128, yes, put 1 in 1. Okay. 40 is bigger than 64, no. Okay. So enter 0 here is 64. If 40 bigger than 32, yes. So 1 at 32 is 8. Bigger than 16, no. Okay, put 0 at 16, and then if 8 is bigger than 8, it's equal, so put 1 here, and the remaining one is 0. So it's not that difficult as you thought. So let's try to convert a whole IP address, okay, example of IP address, when you want to convert them into binary. Okay, I have this value of IPv4 address here, 192.168.20.16. So let's start by the left one first, 192. So 192, okay, you need to know that, okay, 192, okay, you must have a 128, okay, and also 64, and you got the remaining one is 0. Okay, 168 means that if you subtract, okay, 168 with 128, you got 40, and then you don't have 64, you have a 32, and then you don't have 16, you have an 8, and then you have 0, 0. Okay, and then next for 20, you don't have 128, you don't have 64, you don't have 32, and then you got 16, 1. Okay, and then you got 8, you don't have 8 because 16, the remaining of 20 minus 16 is 4. You don't have 8, but you have 4. And then you don't have 2, and you don't have 1. So here you got the third one. And finally 16, so you don't have 128, you don't have the 64, you don't have 32, then you have 116, and then you got remainder 0, means the rest is 0. So you got the whole value of binary for this number here. So next, let's try another number. Okay, so let's say that we have 140.36.24. Okay, so let's take a look at this. Okay, 140. So you have 1 to 8, but you don't have, when you subtract with 1 to 8, you have the remaining of 12. So you don't have 64, you don't have 32, you don't have 16, but you have, because your remaining is 12, you got 8. And then you got the remaining of 4, 8 and 4. Okay, and then you finish all with zeros. Then, okay, we go to the second octet here. So we have 36. You don't have 1 to 8, you don't have 64, you don't have, you have 32. 1 to 8, 64, you have 32. Okay, and then you got remainder 4. Okay, so you don't have 16, you don't have 8, you have 4, you don't have 2, you have 1. Okay, so let's go with 15. You don't have 1 to 8, 64, and 32. You don't have 16. Okay, because 15 is smaller than 16. Okay, and then you have an 8. Okay, which is smaller than 15, closest one. You got the remainder of 7. Okay, next one is 4. Okay, you got remainder of 3, next one is 2, you got remainder of 1, and this one is 1. Okay, and finally it's 24. You don't have 128, you have 60, you don't have 64, you don't have 32, you have 16, you got remainder of 8. Okay, then you got 8, and then you don't have 4, you don't have 2, and you don't have 1. So this is the binary of the next one first. Okay, so let's take a look at the next one. Okay, let's put a number 64, 1, 15. Okay, so we got 12 and you got 3. For example, 64 means you don't have 1 to 8, you have 64, you don't have 32, you don't have 16, you don't have 8, you don't have 4, you don't have 2, and then you don't have 1. Okay, because 64 and 64 become 0 automatically. And then 115, the closest one is not 128, the closest one is 64. So 115 subtract with 64, okay, you should get around 50, is around 61, 64. Okay, you should get around 55. Okay, 55. So you have 115, 51, sorry, 51. So 115 subtract with 64, you get 51. So first, no 1 to 8, we got 164, then remainder is 51. So you subtract 51 with 32, you will get 19. Okay, so 32 we have, okay, and then you got 19. Okay, 19 subtract with next one is 16. Okay, okay, you get 3. Okay, so you don't have 8, you don't have 4, you have 2, and you have 1. Okay, 3. And then you have 12. 12, you don't have 1 to 8, you don't have 64, you don't have 32, you don't have 16. You have an 8, you have 4. Okay, you don't have 0, and then you don't have 1. Okay, finally 3, you don't have 1 to 8, you don't have 64, you don't have 32. Okay, you don't have 16. Okay, you don't have 8, you don't have 4. You have 2, and then you have 1. Okay, so it's easy basically to convert them. Okay, as long as you can calculate the subtraction, okay, by yourself. Okay, later on. Okay, if you think I'm moving too fast, okay, my calculation is too fast for you to catch up. Okay, let's do it a little bit a hard way. So let's start by 164.122.11.220. Okay, this is a little bit hard. Okay, So here 164, you need you need to draw the timetable first. You have 2 power of 0 is 1, 2, 4, 8, 16, 32, 64, 1 to 8. So this is 2 power of 0, 2 power of 1, 2 power of 2, 2 power of 3, 2 power of, okay, this is equal to 2 power of 4, 2 power of 5, 2 power of 6, 2 power of 7. Okay, so this one, 164, the closest one is 2 power of 7, 1 to 8. You got remaining of 38. 36. Okay, and then the next closest power of 2, now 64 is 32. Okay, the next closest power of 2 is 32. So you subtract with 32. And then you got 4. The next closest power of 4 is 2 power of 2. So 4. Then becomes 0. So let's draw the boxes 3, 4, 5, 6, 7, 8. 3, 2 power of 0, 2 power of 1, 2 power of 2, 2 power of 3, 2 power of 4, 2 power of 5, 2 power of 6, 2 power of 7. So this one is 2 power of 7. This one is 2 power of 5. This one is 2 power of 2. And this one is, okay, 0. Okay, so 2 power of 7 is 1. 2 power of 5 is 1. 2 power of 2 is 1. So the remaining one is 0. Okay, so you got the first octet for the IP address. Next, second octet. So 122, the closest power of 2 is 64. Okay, and then you got the remainder is 58. Okay, and then the next closest power of 2 of 58 is 32. Okay, subtract with 32. And then you got 26. Okay, so next closest power of 2 is 16. Minus 16. And you got 10. Next closest power of 2 is 8. Then you got 2. Next closest power of 2 is 1. Then you got 0. So here you got 2 power of 6, 2 power of 5, 2 power of 4, 2 power of 3, and 2 power of 1. So when you conduct the boxes again, 0, 2 power of 1, 2 power of 2, 2 power of 3, 2 power of 4, 2 power of 5, 2 power of 6, and 2 power of 7, you will get, okay, starting from the beginning, 0, 4 to 128, you got 2 power of 6, you got 2 power of 5, you got 2 power of 4, you got 2 power of 3, you got 2 power of 2, 1. Okay, so we got the second octet. Okay, the next one is 11. So the closest power of 2 for 11 is 8. So you got to make it 3. The next closest power of 2 is 2. You got 1. Okay, and then the next power of 1 is 1. You got 0. So here is 2 power of 3, 2 power of 1, 2 power of 0. So you got the octet again. Okay, 4, 5, 6, 7, 8. Okay, you got, this is 2 power of 0, 2 power of 1, 2 power of 2, 2 power of 3, 2 power of 4, 2 power of 5, 2 power of 6, 2 power of 7. You will get, okay, 1 for 2 power of 0, 1 for 2 power of 1, 1 to power of 3. This one is 2 power of 2 is 0. Then 2 power of 3, 1. Then remaining one is 0. Okay, the last one is 220. Okay, 220, the closest power of 2 is 128. Okay, and then you will get the remaining one is 1. Oh no, the remaining one is 92. Okay, so next one is 64. And 64, and then you got 28. And then subtract with 16. Then you got 12. Subtract with 8. Then you got 4. Subtract with 4. Then you got 0. So this is 2 power of 7, 2 power of 6, 2 power of 4, 2 power of 3, 2 power of 2. Okay, so we draw all the boxes again. 8. Okay, 2 power of 0, 2 power of 1, 2 power of 2, power of 3, to the power of 4, to the power of 5, to the power of 6, to the power of 7. Okay, so you don't have the power of 0, don't have the power of 1, you have the power of 2, you have the power of 3, you have the power of 4, you don't have the power of 5, you have the power of 6, and you have the power of 7. Okay, so you get all the binaries by doing it this way. So we completed all the binary. Now let's take a look at the hexadecimal number. Okay, so hexadecimal number, okay, is like the binary, but binary they only have 0 and 1. Hexadecimal they have 0 up until F. Okay, if it's a decimal, okay, it means that it's 0 up until 15. So hexadecimal basically they represent 4 binary bits. Okay, so they represent 4 binary bits. So all sets of 4 binaries represented by one hexadecimal number. Okay, so they are particularly useful in determining IPv6 addresses and also MAC addresses. Okay, so MAC addresses they are used in the Ethernet layer. Okay, they are used in the Ethernet layer so that you can calculate the address of all the NICs connected to a network. Okay, so you need to remember that they start with zeros and they end with an F. Means that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and continue with A, B, C, D, E, F. Okay, so it's a simple term here. Okay, just continue with A, B, C, D, E, F after 9. And what happened when you got after F? Okay, so after F is easy. It become 10, 1 and 0. And then you continue with 11 until 1F. Then you continue with 20. So it's continue on like they have 15 alphabets inside the 15 digits inside a number. So basically IPv6 they have sets of 128 bits. Okay, 128 bits as addresses. So these 128 bits they are separated into, okay, 30 the 128 bits, okay, they are separated into 8 sets of hexadecimals. Okay, 8 sets of hexadecimals. So each 8 sets, okay, they represent each sets within the 8 sets of hexadecimal, they represent 32 bits. Okay, they represent 32 bits. So you have, okay, you have 128, okay, divided by 32 hexadecimals. Okay, okay, they have, okay, this one is 4. Okay, so again I will explain. Okay, the total of hexadecimal, the total bits for IPv6 addresses is 128 bits, and they separate them into 8 sets. Okay, 8 sets of hexadecimals. So one set of hexadecimals, they have 4 hexadecimal. Okay, so this one set, okay, representing, okay, 128 divided by 8 means that they have 42 bits involved. Okay, oh no, I'm sorry. Okay, they have 16 bits involved. Okay, per set. So they have 16 bits involved per set. Okay, and total is 128 bits total. So for 16 bits here, okay, 16 bits means that if you divide it by 4, you can get 4 sets of hexadecimal. Okay, so in case of this number 0000 to FFFF, you get possibility for the first alphabet, for the first number, okay, for the first hexadecimal number, okay, representing 4 binary. The second one represented by another 4, the third one represented by another 4, and the fourth one represented by another 4. Okay, so the total is 128 bits, okay, for one sets of hexadecimal inside the IPv6 address, they have 16 bit. Okay, you have 8. Okay, you got 8. Okay, so this one, for the sets, they are called hexstat. So basically, for one hexadecimal, for one IPv6, you have 8 hexstat. Okay, you have 8 hexstat. So hexstat, okay, for each hexstat, you have 4 hexadecimal. Okay, so basically this is what we have in IPv6. So to convert hexadecimal to decimal and decimal to hexadecimal both ways, okay, you need to do it with binary. Okay, you need to do it with binary. Okay, so using binary is the most simple way, okay, in terms of converting some decimal to hexadecimal. So this one is the answer that we have before. Okay, let's start with the top one. So how do you convert from decimal to hexadecimal? So basically, you just convert them into binary first. So you need to remember, for all the numbers, okay, inside a binary, okay, starting with 0, 0, 0, 0, this represents 0 in hexadecimal. Okay, so 0, 0, 0, 1 is 1, 0, 0, 1, 0 is 2, 0, 0, 1, 1 is 3, 0, 1, 0, 0 is 4, 0, 1, 0, 1 is 5, 0, 1, 1, 0 is 6, 0, 1, 1, 1 is 7, 1, 0, 0, 0 is 8. Okay, 1, 0, 0, 1 equal 9. Okay, 1, 0, 1, 0 is equal A. So we continue on the top. Okay, 1, 0, 1, 1 equal B. 1, 0, 1, 1, 0, 0 equal C. Okay, 1, 1, 0, 1 equal D. 1, 1, 1, 0 equal E. 1, 1, 1, 1 equal F. Okay, so when we try to convert this, okay, make sure you convert it according to this part. So you separate the numbers into sets of 4 binaries. Okay, separate them into sets of 4 binaries. Okay, so 0, 0, 0, 0 is 0, 0, 0, 0, 1, okay, 1. So 0, 1, 0, 0 is 4, 0, 0, 0, 1 is 1. Okay, so 1, 0, 0, oops, I missed 1 0 here. Okay, 1, 0, 0, 0 is 8. 1, 0, 1, 0 is E. Okay, so 1, 1, 0, 0 is C. 0, 0, 0 is 0. So basically, in hexadecimal, this IPv4 address is C0, A8, 1, 4, and 1, 0. Okay, so basically like that. So let's take a look at the second one. So we separate them into 4 sets of binary. Okay, so this one, 1, 0, 0, 0 is 8. This one is C. This one is 2. This one is 4. This one is 0. This one is F. Sorry, F. Then this one is 1. This one is 1, 0, 0 is 8. So you'll get the number is 8C, 24, 0F, and 18. Okay. And then finally here, okay, separate them again to 4 binary. So here you have 4, 0, dot, this one is 7, 3, dot, 0, so C, dot, 0, 3. Okay. Okay. So in order to convert it back to decimals, you use the same way. Okay, you separate them, okay, into each digit of hexadecimal, and then we convert each digit into 4 binaries. So 3 is 0, 0, 1, 1, and then you got 0, 0, 0, 0, and here you have 1100. Here you have 0000. Here is 0011, and then here you have 0111, and here you have 0000. Here you have 0100. Okay, then throw you got the binary. You add every number according to the decimal number value. For here is 1 to power of 0 and to power of 2, so it becomes 3. So here it become, this one is 2 power of 2 and 2 power of 3, so it become 12. So here total is 115, and here the total is 64. You got the decimal again. So it's not that difficult, you just need a lot of practice for it. So basically, the instruction is that for you to convert the hexadecimal to decimal conversion, okay, convert the hexadecimal number to 4-bit binary strings, create 8-bit binary grouping starting from the rightmost position, and then convert each 8-bit binary grouping into their equivalent decimal digit. Okay, so for example, you got D2, separate them into 4-bit, which is 1110 and 0010, and it become an 8-group grouping, and then you convert all this into decimal. Add all of them, and then you got 210 in decimal. Okay, that's all for the course for today. So hopefully this will be beneficial for you in learning how to convert the binary and hexadecimal later on. Okay, so I will try to improve my delivery of the video later on according to your comments in the Google Classroom. Okay, and also the form, Google form involved for the attendance of the lecture. So any questions, please post them inside the Google Classroom video link comment. Okay, please avoid I would like to avoid commenting on the YouTube page due to it's become public, and hopefully you are more comfortable to comment with me inside the Google Classroom comment platform. So that's all for today. I see you guys in the next lecture. Hopefully you guys will stay safe, stay at home, and stay study. Inshallah, don't forget to like and subscribe my channel. Okay, I see you guys in my next video. Thank you very much for watching.